Hi friends, welcome back to my channel on statistics. If you are seeing my videos first time, then do subscribe. Let's go to the topic. In this tutorial, I am going to discuss brief introduction about non-parametric inference. We all are know that non-parametric inference have good weightage in GATE exam. Okay, GATE statistics. Okay, GATE statistics and some few competitive exams also. Non-parametric less weightage, but it is important topic if you take the application wise and all things also. First we can see this is my content of this tutorial. First we can see what is the introduction about non-parametric inference, then what are the some basic concepts. I will already discussed few basic concepts about non-parametric, that is called order statistics, probability integral transforms. Okay, order statistics, then probability integral transforms. Okay, then empirical distribution and then tolerance limits. All things comes under the basics of non-parametric inference. Here non-parametric inference totally deal with order statistics. Okay, order statistics is most important. Okay, then we can discuss about use statistics. Then we can discuss about these are the tests available in the non-parametric literature. Okay, tests for randomness, then rank order statistics. Then we can go to the goodness of fit problems, chi-square and Kolmogorov-Suvorov test. Okay, now we can see. First, we can see what is the definition of statistical inference. Then we move to the non-statistical inference. Means non. Okay. Statistical inference is the process of analyzing sample data in order to deduce properties of an underlying distribution of probability. Means, see, we all know what is the statistical inference. Drawing conclusion. For example, I have this population. Then I draw some IID random samples. Then I can analyze some. Either I can apply estimation or I can apply testing of hypothesis. Then I can draw the some conclusion about the total population. This is called statistical inference. It is assumed that the observed data is a sample from a large population about which we want to infer. Okay, basic task of statistical inference may be categorized as estimation of distribution parameter. Estimation means it will be point estimation, it will be interval estimation. Generally in estimation we mainly discuss about mean and standard deviation. Okay, this is our location parameters, this is our scale parameter. Location parameter, standard scale parameter. Here mean is highly in place of non-parametric we can use median. Okay, we can discuss that also. Okay, comparing two population parameters, mean and variance, this will be testing problems. Then we are going to be testing of hypothesis problems. Okay, first we can make some assumption, then we will going to reject accept. This is all things under the testing of hypothesis. This is totally related to the statistical inference. Now we can see this is some examples. Okay, statistical methods works under certain assumption. Means in parametric inference compulsory we have some assumptions. Okay, see, data should be quantitative, population as a normal distribution, sample size is sufficiently large. But in practice that is not always the cases. Data may not satisfy one or more assumptions need to be applied. Parametric means it compulsory should be satisfy some properties. Okay, but where in non-parametric there is no any assumptions, we can apply directly based on the data. We can discuss that also. Okay, introduction. Now we can see some examples also. See here, data may be ordinal or categorical. Data means ordinal and categorical means what? Okay, variables have natural and order categories, and distance between categories is not known. Okay, population size may be too small or too be treated as normal. Okay, these are some assumptions and all things also. Okay, this is the case of non-parametric inference. If the normal distribution is not appropriate, it is common to consider as the possibility of a transformation of the data so that normal theory methods may be applied to the transformed data. Else if normal distribution conditions are not satisfied, then we are move to the say some exponential distribution, some gamma distributions, different distributions. Then we can switch to the non-parametric distributions. Okay, now onwards our main motto started. It is called non-parametric inference. Okay, see, this is the definition. A statistical method is called non-parametric if it makes no assumption. Means there is no assumption. For example, the sample should be IID. This sample can be drawn from normal population. Data should be qualitative, data should be quantitative, like that. Okay, and the population distribution or sample size that is contrast with distribution free. Means distribution means there is no any parameters involved in the distribution. Methods which are not phenomena. Okay, now we can see some methods also, all things also we can discuss here. Non-parametric methods, very little or no assumptions required about the form of the distribution of the population. Okay, example, it might be assumed that the data are from a population that has continuous distribution. Okay, distribution procedure means if no parameters involved means it is distribution pre-parameter. Okay, now we can discuss some uses of non-parametric with examples also. The following are some situations where you use non-parametric procedure inappropriate. The hypothesis to tests involve no population parameter. The data have been measured on a weak scale so that assumptions necessary for a valid use of parametric procedure are not. Means, for example, you can take the, for example, I have mean. Okay, mean is location parameter. In it is mostly used in parametric inference. In place of mean, we use median in non-parametric. Why? Because mean is based on all observations. Okay, median is does not depend upon all observations, so we can generally mostly use median and ranges. Okay, the data may be considered counted data or ranked data. Data may be qualitative, that is ordinal or nominal. Okay, in class of 100, the CGPA distribution is not typically normal. The distribution of SGPA and CGPA is not homocity. These all are the examples of non-parametric. Now we can, if we see the advantages of non-parametric, these all are the some advantages. See here, assumptions are less in non-parametric, need not to involve the population parameters, small chance of being improperly used, applicable to data measured on weaker scale. Okay, easy to understand and sometimes it will be difficult also. Okay, computations are quick and can be easily performed. Okay, since most parametric procedures depend on a minimum set of assumptions, they are called wider applicable. So this is all of the few advantages. Some disadvantages also there for non-parametric inference. Okay, may waste information upon actual values are not considered. For example, see, there is a drawback of why median is not become the ideal measure of central tendency. Means median is not based on all observations. Okay, median is not based on all observations. If you calculate the median, you can just find the ascending or descending order. We can approximately we can find values, so it will be not based on all observations. Sometimes it will be going to the wrong conclusion also, sometimes it is going to the wrong conclusion also. That's why in parametric inference we prefer mean more. Mean is the most. Okay, manual computation is difficult for large samples. I already discussed this. Tables are not widely, for example, you can, if you take the, for example, you have chi-square test tables. Okay, Kolmogorov symbols table, but if you sample size increases, that time difficult to find the values also. Okay, less efficient. I already discussed, because of it will not depend upon our observations. Okay, now we can see here onwards our procedure will be start, our class important topics are started. Non-parametric estimation of location or origin. See, generally when you see this, okay, points you can easily estimate also, totally deal with other statistics. Okay, non-parametric mostly deal with other statistics. Okay, for all 0 less than p less than 1, let jp denote the pth quantile. Pth quantile. Okay, here we don't discuss about mean. Here always we deal with median. Okay, that is fx of jp equal to p. Okay, this will be clear. Fx of jp equal to p. A point estimation of jp is often given by the corresponding sample quantile. Let xr be the rth order statistics. Order statistics means we all are know here. See here, x1 denotes the small order statistics and xn denotes the larger statistics. I have made video on order statistics, you can see now also. Okay, if n plus 1 multiplied by probability is an integer, okay, say p equal to r upon n plus 1, then xr is the point estimate of r upon n plus r quantile. Okay, you can there's some examples also there, you can understand. This will be simple. Okay, if n1 plus p is not an integer, okay, if it will be integer then it will be easier to calculate. If it is not integer, then it will lies between two limits. Okay, two statistics. Then jp is obtained by linear interpolation of xr and xr plus formula. This is formula. Okay, this is the formula. Okay, n1 plus p minus r plus 1 divides by r minus r plus 1 into xr plus n plus 1 into p into r minus. This is the formula. Okay, now we can see examples. See, I have some values. There is no any parameters or distribution. They didn't tell anything. Okay, they give just some samples. Then find the 0.25th quartile and 0.35th quartile. Now we can see how we can find. See, first I can arrange values in ascending order. Okay, see, first I will arrange x lower order statistics and higher order statistics. Here n is 11. Okay, 1 2 3 4 up to I have 11 values. Now my n is 11. Now what is the formula? First we need to find n plus 1. Then for first part we give 0.25 per quartile, 0.25. So 0.25 code. So I just multiply n plus 1 with 0.25. N plus 1 with 0.25, I got 3. So 3 is an integer, therefore JP is the what? X3, 11.4. Answer is finished. But when you can take the 0.35, okay, when you take the 0.35, then you can multiply with, okay, when you can multiply with 11 multiplied by 0.35, you got float value, means not integer, 4.2. Now our JP value lies between 4 and 5. Okay, order statistics 4 and 5. Now how you can calculate? You can just apply the, this is the, now we are going to the apply formula. Okay, here n plus 1 come outside and divide, then finally you got this expression. So now how to find 0.35? You can just apply the formula from where this formula, this is formula. You can just, when we can apply this formula, you can get the this thing. Okay, finally you got one JP value. Okay, now up to now we can see the, now we see point estimation. Now we can see confidence interval. How we can estimate confidence interval for the given parameter? See, we all know that for confidence interval it follows binomial distribution. Okay, binomial distribution. The narrowest interval approach, choosing r comma s such that s or s minus r is the minimum for fixed alpha and involves trial and error solution to make. This is the form of confidence intervals. Okay, this is, okay, summation I equal to 1 to r to s minus 1 ni p power I 1 minus p means either q power n minus 1 at least 1 minus alpha. See, for this is narrowest interval approach, this is equal tail approach. Okay, this is equal tail approach. Here limits are 0 to r minus 1, here k equal to 0 to s minus 1. Okay, when you see the examples, you can easily to understand. See, suppose that you have a sample of size 9. What is the confidence that the median is between x3 to x8? Here you can observe this a median, so median means 0.5. 0.5 is the our p value. Okay, when you can say the, when you can say upper quarter or lower quarter, that time it will be going to the 0.25, 0.75. It will be depend upon question. Okay, now we need to find what is 3 to 8. This is the formula. 3 to 8 minus 1 means 7. Here total is n. You can use table also, you can use R coding also, you can use Python coding also, but simple also we can calculate. Simply also, see, here I have total probability. For example, how I can calculate this means, this is total probability equal to 1. So I have starting from 3. So I convert to 0, 1, 2. Okay, it will comes under minus. Okay, 0, 1, 2. Okay, then up to 7 we have. Here 8 minus 1 means 7. Here 8 and 9 missing, so 8 and 9 also included. So when you can add up, then you can get minus, then you can get the value. Okay, you can just apply definitions. Now we can see there are some testings available. We already discussed about that, goodness of fit and randomness, all things also. Now we can discuss few test statistics with brief examples. Okay, not very tough. Okay, testing of hypothesis about the central tendency of the distribution. The problems is specified as a given x1 up to xn, a sample from a population. How to test that the central location of the population is mu. Okay, now we can see in generally in statistical inference with parametrics involved, means parametric inference, we use z test or t test for testing means, but we are dealing with here medians, so we use sign test or Wilcox rank test. We can discuss this. See, in parametric setup, test is done using z test. The test statistics is s bar minus mu upon sigma by root n. Here when is standard deviation is known, when standard deviation is unknown, we use t test with n minus 1 degrees of freedom. We all know this. Okay, But in non-parametric, we replace sample mean with sample median. Sample mean with sample median. That time we have two tests available. It is called sign test, and one sample will call sign rank test. This is most appropriate than sign test. We can discuss with examples also. Okay. Now we can see test for location for paired samples. Paired samples we can use t-test for paired data in parametric inference, but in non-parametric we have one. See, paired t-test is based on the difference between the values of a singular pair xi comma y. Y here y equal to lies between 1 to n. Typically y is detected from x. This formula for a paired t-test. Okay, we discuss this thing in parametric inference. Okay, but in this is the form test statistics t equal to summation di by d square minus this it follows with t with 1 minus degree separate. In non-parametric method we have paired sign test, paired Cox sign rank test. Okay, same that here pair is okay. Now we can see up to now we can see for related to the median. Now we are going to the discuss about standard deviations also to test the equality of central location of two populations based upon the sample given x1 and y1. Then test statistic is in parametric situations are, see, this is z test. Okay, we already know this for testing for two sample means. Okay, when a variance is known, when variance is unknown, these will be different games are different cases are available. Okay, but in non-parametric test we have Wilcox rank sum test, then Mann-Whitney U test. Okay, we can discuss the examples. When we discuss the example, then you can easily understand this is will be related to the variance question. For testing two variances we use F test. Okay, but in non-parametric we can use mood test, Freud answer test, checkmate test. Okay, for goodness of it we can usually generally use chi-square and Simrow test. Okay, chi-square and Kolmogorov-Simrow test. Okay, these are also some important. Okay, now we are going to the test. Up to now we discussed which tests are available in the literature based on the non-parametric. Now we are going to the discuss brief introduction about theory with example. Brief introduction about theory with example. Test for randomness. As name suggests, randomness means random data. Okay, random data. See, in order to arrive at a conclusion about a distribution, the basis of a sample, we often need to have a random sample. That is sample is taken without any bias or pre-designed rule or selection. Okay, or to support some purpose, etc. We all know what is the random sample. It will be simple replace or without replace all things. Also it is important to maintain the order in which the samples are chosen. Okay, this is also okay. Now you can see this is example. When you understand this example you can easy to analyze. Okay, see, this is example. Consider you are picking 12 balls from a basket with equal and large number of red and blue balls. Okay, here I have 12 red balls and sorry, combination of blue and red balls I have 12. Here I draw some possibilities. Okay, I have six blue and 6 red. Okay, then I have blue red blue red blue red blue red, then I have 3 reds, 6 blue, again 3 red. These are some possibilities. Okay, again I have this possibility also available: red blue blue, red red blue red red, blue 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 red. Okay, see, when you write the sequence you can get different how many ways you can get here 12. when you when you say with replacement or without replacements you can got nearly 12 square. Without replacements you got 12 c2. Okay, with replacement you got 12 square. Okay, n power n. Okay, see, given an order sequence of two or more types of symbols, a run is defined to be succession of one type of symbol that is succeeded by preceded by another type of symbol. See, you will understand. See, here I have only one possibility. Here I have one, so I have two runs. Okay, here see, I have blue and again red, blue and again red. So when you can add up total, you can get the 12 runs. See, here I have one run. Here I have two runs. Here I have one run. Finally, we have three runs. See, here also 1, 2, 3, 4, 5, 6, 7. Okay, here I have 7 runs. It's just based on the total number of runs means now we can see the some tests are available for non-parametric. See, it is clear from the above example, that is, if the number of runs is too large or too small, then it is unlikely that